Hello, I'm Amara Rasgus with Consulting Specifying Engineer. I'm here today with Dennis Sczomak, and our conversation is going to be about chillers and chilled water systems. First, a little background about Dennis. Dennis Sczomak leads Peter Basso Associates technical staff as Director of Engineering, driving a culture of quality, innovation, and design excellence throughout its engineering teams, as well as fostering technical proficiency of engineering team members. Dennis oversees the development and maintenance of design standards and standard processes to improve the efficiency and effectiveness of engineering operations. Dennis has 35 years of experience that includes HVAC, plumbing, and fire protection design, heating and cooling plant evaluation and design, cogeneration system feasibility investigations and studies, and detailed energy conservation studies using computerized energy analysis. Dennis has been involved in projects for a variety of facility types across many market sectors. It's a pleasure to chat with you today, Dennis.
Glad to be with you. Thank you.
All right, well, let's get started. Let's set a baseline. What are some of the current trends that you're seeing with regard to chillers and chilled water systems?
Well, really, one of the biggest trends that we're seeing is not directly to do with chillers and chilled water systems, but how they can be related to heating systems. As we drive to make our buildings more energy efficient, we need to capture the heat that the chillers are rejecting. A typical chiller takes the heat from a building or process and rejects it to the outdoors through a cooling tower on a water-cooled system, or through to the air through a dry cooler or condensing unit on a air-cooled system. But as we drive we need to capture that. There's very many times that the building needs both heating and cooling at the same time. So that's the biggest trend, is how we can utilize heat recovery chillers and then capture that heat.
Right. Okay, good. Thank you. So talk a little bit about net zero. How is net zero affecting chillers and chilled water systems?
Well, driving towards net zero, it means we absolutely need to capture every BTU of energy in the building, and use it in the building where needed. And if we're driving towards net zero carbon neutrality, then recovering heat from chillers is very important, because most often your heat would come from natural gas or other carbon fuel sources, and by using a chiller, which is most commonly electrically driven, and recapturing the heat from the chiller, then that helps with net zero on carbon as well.
Yeah, right. Thank you. That's a very topical type of subject, I think, to talk about right now, especially because everyone is concerned about energy efficiency.
Yes, and it really is, and it really takes a holistic view towards building design. We can't view a chilled water system in its compartment and a heating system in its compartment without how they relate to each other. In order to have a heat recovery chiller, you have to have a heating system that's compatible with it. Many buildings, especially existing buildings or buildings on many college campuses, actually have their central heating source as steam, and steam is at a very high temperature, and it's not compatible with with any heat recovery chiller that I know of. There are many buildings that take that steam and convert it to a hydronic hot water heating system in the building. But if it's an older design, or even some newer designs I've seen, they're distributing that hot water at a temperature that's too high for the equipment, that's too hot of a temperature for the equipment that's available for heat recovery. So on an old building, that may need retrofit of the heating system to be able to work with a lower temperature. Or on a new building, when I say we you need to be holistic. You need to think about, how can we design our systems to work at a temperature that accepts and is compatible with heat recovery chillers.
Right, good point. I'm going to shift topics here just a little bit. What do you suggest? What can design engineers do to future-proof chilled water systems?
Well, it goes very much related to what I just talked about. If even if you're not going to put in a heat recovery chiller, maybe if it's not in the budget or in the concept for your project, there's other technologies that can be utilized and more easily for energy efficiency. If you're designing your heating system, and again, I'm talking about heating system when our topic is chilled water system, but it's a big picture view. Design your heating system to utilize lower temperature hot water. It's in the 130, maybe 140 degrees Fahrenheit maximum range. And then that opens the door to utilizing heat recovery chillers, so that down the road, or using other heat recovery devices that might come into play down the road. The other thing is to be smart about your chill water system design. There's a relationship between the chiller selection, pumping system design, pumping temperature differences that you use. There's many tools that you can use there to drive the efficiency of the chill water system and help in the future as you adopt other technologies.
Sure. Okay. Well, the last thing I wanted to chat about was operations and maintenance. How should operations and maintenance needs be considered with these latest trends?
Well, it always needs to be a consideration. There are some newer technologies coming out, some different refrigerants being used in some chiller heat recovery devices that I've seen that are newer. And I think it's important to keep an eye on those newer technologies, to use them when appropriate, but also to use some caution, because in the end, the owner and operator of the building is stuck with this piece of equipment for a long time, and we maybe too much of a catchphrase, but you can be on the leading edge, but not the bleeding edge, and try to do your best to avoid that if you can.
Great. Okay. Well, thank you. I'm here today with Dennis Sczomak from Basso Associates. We've talked about chillers, chilled water, and a whole lot more. Thank you so much for your time today, and goodbye.